very good question. This question is like exam type question. Like, see, they have given you one data and they are asking you like step 4. They are not asking you to calculate step 2, step 3. Usually students make mistake that they think that these are instead of these normal strains, they think of these strains as the principal strains. So they do make a mistake over there. Okay, so we will do step by step and that will help us to revise the Mohr circle, and afterwards we will start the strain. I think so it should be strain rosette, which should be the next topic. Strain rosette here. Because with section B, I'm also their tutor for the lab class. We have worked on like on the instructions of the strain rosette, but we have not gone into the details that how these equations are developed. So if everyone is fine, then we should start the class. Okay, guys.
Yes, sir.
Most probably next week as well we will be having extra class, because what I want that I should finish the syllabus with you on online, and when you will come here, then we can have focus on psychomotor evaluation, and I can arrange extra class if required by any section. In general, section C and D, they are very high quality students. Section B is also good. Section A में थोड़ा सा है कि I don't know why they are not working much harder. तो बाकी आप तीनों sections they are doing great. But as a teacher, it's my job to bring all the sections to the same level. So let's start, guys. Epsilon x is minus 400 microstrains. ठीक है जी. Epsilon y is 200 microstrains, and gamma xy is 150 microstrains. ठीक है जी. Question is we have to determine the maximum in plane shear strain. ठीक है जी. And absolute maximum shear strain. Question is clear to everyone? So the
Yes,
steps
sir.
are first we have to calculate the principal strains, and from the principal strains then we will calculate the maximum in plane shear strain. So let me start the recording as well. So let's start with this numerical. Okay. So first, guys, first step, can you please calculate the average strain? Average strain, please report the average strain.
Sir, minus 100.
Minus 100 microstrains. So coordinates of your point C will be minus 100 microstrains and 0. ठीक हो गया जी? That's fine.
Yes, sir.
Coordinates of your reference point A, that will be minus 400. Epsilon x is minus 400. So coordinates of point A will be minus 400 microstrains, and shear strain कितना होगा? Gamma xy by 2. ठीक है जी? Because on the vertical axis you have gamma by 2. ठीक है? So what's the value of gamma by? Sorry, what's the value of gamma by 2? 150 over 2, 75 microstrains. 75 microstrains. ठीक है जी?
Yes, sir.
Done. Okay, next is please calculate the resultant or radius. Resultant or the radius. Epsilon x minus epsilon y over 2 square plus gamma xy over 2 square and under root of all of this. So please calculate the radius or the resultant and let me know the answer. It means 0.000309. ठीक है जी? So it's already very small value. So round it. ठीक है? So let me draw the figure now. Okay जी. So we have average point minus 100. चलो ठीक है जी. So this one we can keep, इसको ऐसे कर लेते हैं. I think 100, 200 and 300. 100. I'm keeping 100. ठीक है? ये थोड़ा सा मुझे एक्सटेंड करना पड़ेगा. $300 and let's say this is 400. Again, this is radius आपका कितना है? 309.
9.
So this is 100. This is 200. 300. Minus 400. So this is your epsilon axis. This is 100. This is 200. This is 300. This is minus 100. Minus 200. Minus 300. Okay, and this is gamma by 2. So first we will mark the center point. Center point has the coordinates minus 100 and 0. ठीक है जी? So this is your point C. थोड़ा सा एक सेकंड है. Okay, reference point has coordinates minus 400, minus 475. So somewhere here. ठीक है जी, दिस इज योर रेफरेंस पॉइंट ए, ठीक है जी, रेडियस इज 309, minus 100 minus 300, it will be somewhere here, second point, and minus 100 plus 309, so 209. Actually, I do not have the compass, okay? So when you guys will be drawing with the compass, there should not be any issue. ठीक है जी, आपको इस तरह कैलकुलेट नहीं करना पड़ेगा. Okay जी, let's draw the Mohr circle. ठीक है जी. So your first target. अच्छा, एक और चीज important over here is your reference line is, sorry, not drawn correctly, is CA. This is the first time we are having a reference point on negative side. Okay, so this is your reference line CA. So our first step is we need to calculate the principal strings. So this one is epsilon 1, which is positive, and this is your second point, which is your point B T, sorry. So this is your epsilon 2. Okay, so very simply I can say epsilon 1 is epsilon average plus the radius. ठीक है जी, epsilon average is minus 100 plus the radius is 309. Guys, always do maximum number of steps. Do not skip the steps, because if somehow you are doing it wrong, you can get good marks of the steps. If you will omit the steps, so if you are doing right, you can get the marks. But if you are doing wrong and you have not done the steps, then I will like it will not be possible to give you any mark for that. So be careful about this thing. ठीक है जी, then epsilon 2 epsilon average plus minus half. So epsilon average is minus 100 minus 309. So this is minus 409. Clear ji? So this
Yes,
is
sir.
your case. This is your case in which you can say this is your case in which you can say one of the principal strain is positive and the other principal strain is negative. Okay? So in this case, now guys, there are two things. when you will be calculating absolute and maximum in plane shear strain, please keep thing in mind that like about the question that how many marks the step carry. Okay, if such question comes, you need to know that how much marks the step carry. Okay, like if it carries 1 mark for the computation of absolute maximum shear strain, then you just need the formula and you can compute it. Otherwise, if it carries more marks, then you need to draw the figure. So in this case, over you can say maximum in plane shear strain and absolute maximum shear strain. ठीक है जी? For this case, they are क्या है जी? Absolute maximum in plane and absolute maximum. So the value is epsilon 1 is 209. ठीक है जी? 209 minus 409 minus 409. So your answer for the absolute maximum and maximum in plane shear strain will be 209 plus 409, 618 microstrains. If anyone has any query about this, let me know. I can explain it again about the calculation of maximum in plane and absolute maximum shear strain.
सर ये हर केस में सेम ही होगी एब्सोल्यूट और इन प्लेन shear स्ट्रेस या चेंज भी हो सकती है?
किस केस में?
सर
किस केस?
जब दोनों के ऑपोजिट साइंस है।
जब when you will have one positive one negative तो ये सेम ही होगी, it will not change. ये तो एक ही possibility बनती है ना. You will only have one possibility when you have one principal strain positive, other principal strain negative. Positive वाला जो होगा positive principal strain will be epsilon 1 and negative principal strain will be epsilon 2. ठीक है जी?
ओके सर।
ठीक है? If this is clear or if you want, अगर कोई query है तो you can ask me. जी उज़ैर थोड़ा सा ऊंचा बोलना है प्लीज।
20 डिग्री क्लॉकवाइज रोटेट किया हुआ सर, अगर इस क्वेश्चन में हमें अगर ये बोल दे कि एलिमेंट जो है वो 20 डिग्री क्लॉकवाइज रोटेट कर गया है तो इस पे क्या इफेक्ट पड़ेगा?
किसके ऊपर?
गैमा मैक्स के ऊपर, मैक्सिमम इन्फ्लुएंशियल स्ट्रेस के स्ट्रेन के ऊपर।
उसके ऊपर तो कोई फर्क नहीं पड़ेगा।
राइट
देखिए let me explain to you the question which you have asked. See, this is your principal plane. ठीक है जी? This is your principal planes. Fine. So over the principal planes you have maximum and minimum normal strain. This is your major principal strain, this is your maximum principal strain. It does not matter if your theta is rotated like over here or it is over here or it is over here. We are not concerned with this. Principal strains are the normal strains which are over the principal planes. ठीक है जी? जो principal planes है we are only concerned over here कि उसके ऊपर strain क्या है. That will give us the principal strains. This will not give us a principal strain value. This will not give a principal strain value. This will not give a principal strain value. Okay.
Okay, sir.
If this is clear, then we are proceeding to next question. Not next question, next topic. So let's start strain rosette. You guys have studied strain rosette in your lab class, but now we will study in detail. Let me open up one more file. Just give me a moment, please. So can you see this file?
Yes, sir.
Yes, sir.
Okay. Okay, good. And this is strain transformation, and we are, this we have done today. Okay. So let's start with our new topic, that is strain rosette. In your lab classes, you guys have studied that strain gauges can be used to measure the normal strains. ठीक है जी. So strain gauges will only measure the strain in the direction in which it is attached. If it is attached in X direction, it will measure the strain in X direction. If it is attached in the Y direction, it will measure the strain in Y direction. ठीक है जी. If it is like placed out of the plane, it will measure the strain only in that direction. So strain gauges can only measure the strain in the direction in which it is attached. They are not what you say, they cannot measure the strain in the perpendicular direction, ठीक है जी, perpendicular to the strain gauge direction, or shear strain, ठीक है जी. Now what we are going to do, we have the data, normal strains from the strain gauges. Now with that data, strain data, we want to calculate the shear strains, we want to calculate the normal stresses and shear stresses, ठीक है जी. So how we are going to do, we are going to derive some material property relationships, ठीक है जी. And we will also focus that how we can get the shear strain value from the normal strains, because we are just measuring normal strains, we are not measuring shear strains or the stresses, ठीक है जी. So how we can get that thing? So when performing a tension test on a specimen, the normal strain in the material is measured using an electrical resistance strain gauges. In our lab class with section B, we have what you say, we had an overview of different types of strain gauges. But the most commonly used type of the strain gauge is an electrical resistance strain gauge. The most commonly used type of the strain gauge is the electrical resistance strain gauge. It is very, what you say, easy to use and easy to carry. So, but the only thing is, at present, if you go with the price of the electrical resistance strain gauges, if you go with the price of what you say, Japanese strain gauges, they are about like 1100 per strain gauge. But if you go with the price of the Chinese strain gauges, they are about 330 rupees per strain gauge, including the excise duty and the GST and everything. Okay, so electric Chinese strain gauges we have used here. I have used, one of my MSc student have used, and they work well. So now the thing is, like when we are doing the tension test over here, we do not use the strain gauge, we will use the extensometer. Extensometer will measure the deformation. So what we will do, we will put the load on the steel bar, ठीक है जी, and we will measure the increase in the length or the deformation. ठीक है जी, and we will compute this data. ठीक है जी, sorry, record this data, and later on from that data we can calculate the strains. ठीक है, but remember one thing, we are only measuring the strain in the longitudinal direction. We are not measuring the strain in the lateral direction, because when we do the what you say tension test over steel bar is elongated along the longitudinal direction, but along the transverse direction its dia is reduced. ठीक है जी, so lateral strains are always negative in magnitude to the longitudinal strain, and there is a relationship which was developed by Poisson's between the normal and the lateral strains. So lateral strains are basically minus times mu, which is your Poisson's effect, into the longitudinal strain. So generally in case of the steel, lateral strains are 30% of the longitudinal strains. So electrical resistance strain gauge consists of what you say a wire grid or a piece of metal foil bonded to the specimen. So if you see this, this is your electrical resistance strain gauges. So these are the metal grids, okay, and they are, yes, please keep your mics mute. So this is the electrical resistance strain gauge being shown here. This is the metal foil, which is basically, you can say, fixed on the base. Okay, and these are the leads or lead. Okay, lead wires. So these wires we can extend. When you get the strain gauge, particularly the Chinese strain gauges, they have very short leads. So you have to attach the wires so that we can connect those wires to the data acquisition system. Because as the load will be applied, load is stress. Sorry, stress is force per unit area. Cross-sectional area is fixed, so with changing load, the stresses will change. So with changing stresses, the strains will be produced. So strain gauges will measure the strain and it will be recorded in the computer system. Okay, so we have that assembly. So we have that assembly in our lab. So when we will, guys, just a moment, please. Sir, okay. So for a general loading on a body, guys, about this data acquisition system, I will, when you guys will come here on campus for the lab, I will show you how to attach the strain gauges and how to work with them. It's very simple, but the only thing is that these strain gauges can only be fixed on one surface. Once it's fixed, it cannot be reused or reattached. The assembly which we had made in the lab, over there we have steel beams, and over the steel beams we have fixed the strain gauges. And we do not detach them. Every year we just use them. हम उसे detach करके, we do not put it on the new surface. They are just kept at the surface where they are. So for a general loading on a body, however, the strains at a point on its free surface are determined using a cluster of 3 electrical resistance strain gauges. Now, what is strain rosette? Strain rosette is basically a cluster of strain gauges in which there should be at least 3 strain gauges. The number of strain gauges can be 4 as well, but minimum there should be 3 strain gauges. Now, if you see this, this is one cluster of strain gauges. This is your horizontal x-axis, or you can say positive x-axis. These are the three strain gauges: gauge A, strain gauge B, and strain gauge C. So these angles with respect to x-axis, ठीक है जी? So this angle with respect to x-axis, we need to measure that. This is what you say, counterclockwise towards A. So this is theta. The angle with respect to horizontal x-axis is theta p, and angle for this strain gauge C with respect to horizontal x-axis is theta c. The strain, these strain gauges will give you value of strain. Let's say this strain gauge A will give you a value of strain epsilon A. This strain gauge B will give you a value of strain epsilon B. This strain gauge C will give you a value of strain epsilon C. ठीक है जी? So these three values will be known to you. Other three values will be this theta A, theta B, theta C. Guys, when you are measuring the values of theta, ठीक है जी? Because in the paper as well, if such question come, you have to compute the values yourself. So in that case, always remember that we have to what you say, the what you say, over reference must be same, and we must move in the same direction. If you are moving in the counterclockwise direction, that is positive. If you are moving in clockwise direction, if you are moving in clockwise direction, it will be negative. ठीक है जी? So I would suggest you guys to always move from the positive x-axis in the counterclockwise direction. ठीक है जी? So for a general loading on a body, however, the strains at a point on its free surface are determined using a cluster of three electrical resistance strain gauges arranged in a specified pattern. There are different patterns. ठीक है? Later on, I will show you there is 45 degrees pattern. ठीक है जी? You can see this. This is 45 degrees pattern. It means three strain gauges are attached at an angle of 45 degrees. Now, if you want to measure the theta A for this, ठीक है जी, angle. So if we measure with respect to positive x-axis, so theta A will be 0. Moving in counterclockwise direction, theta B will be 45 degrees. Moving from reference to C, theta will be 90 degrees. ठीक है जी? Theta will be 90 degrees. Similarly, we have 60 degrees strain rosette. So moving from the horizontal x-axis, ठीक है जी? Moving from the horizontal x-axis, ठीक है? So this theta A will be 0, theta B will be 60 degrees positive. Moving from x-axis to C, theta C will be 120 degrees. Remember one thing, that the reference and the direction in which we are moving, they must be same. They must be same. ठीक है जी? You cannot change the reference while you are measuring theta A. ये नहीं है कि for theta A the reference is different, for theta B the reference is different. In that way you will get the wrong answers. Is this point clear? So this pattern, this pattern is, let's say we have over steel beam, so we will place the we have placed the strain gauges in one particular pattern. Okay, so pattern will give you different value of theta and different value of the strain, but the final result should be same. Fine. So this pattern is referred to as a strain rosette, and in the strain rosette there should be at least 3 strain gauges, and each strain gauge will give you the value of the normal strain in the direction in which it is attached. So this pattern is referred to as strain rosette, and once the normal strains on these 3 gauges are measured, the data can then be transformed to specify the state of the strain at the point. Now the thing is, what you are getting from this strain rosette, you are getting theta A, theta B, theta C. You are getting epsilon A, epsilon B, and epsilon C. But this is of no use to you, because what is useful for you is you want to know maximum main plane shear strain, you want to know principal strains. But to calculate principal strains and maximum in plane shear strain, you need to know the plane state of the strain. You need to know epsilon x, you need to know epsilon y, you need to know gamma xy, but it is giving you raw data. ठीक है जी? So now from this raw data, which is epsilon A, epsilon B, epsilon C, theta A, theta B, theta C, there are equations from which you will get your plane state of the strain, and then you can use the plane state of the strain to calculate. ठीक है जी? You will use the plane state of the strain to calculate principal strains or maximum in plane shear strain, which is of useful to you, which you will use further in your analysis and design. ठीक है जी? So this pattern is referred to as strain rosette. And once the normal strains on the three strain gauges are measured, the data can then be transferred to specify the state of the strain at the point. Is this point clear? So, जी
सर ये जिस तरह 45 और 60 डिग्री पैटर्न है इनमें थीटा ए 0 है, तो अगर हम थीटा ए को 45 से स्टार्ट करके नेक्स्ट आर्मर 45 या 60 कर लें तो वो भी 45 या 60 उसे हम डिफाइन करेंगे.
एक सेकेंड, यू हैव सेड, आपका क्या मतलब है कि यहाँ पे ए आ जाए, ओवर हियर बी एंड दिस विल बी सी, ऐसे कह रहे हैं?
यस सर.
हाँ, तो उसमें फिर होगा कि योर थीटा ए will be 45 degrees, theta b. I will draw the figure. आप after जब हम figures draw करेंगे ना, over there do let me know. I will draw the figures.
सर वो फिगर समझ आ रही है, मैंने बस ये कंफर्म करना था कि उससे भी हम 45 स्ट्रेन रोजेट पैटर्न कह सकते हैं या नहीं.
गुड क्वेश्चन. मेरे ख्याल से कह सकते हैं, because 45 degrees is basically it basically tells us that the difference between the strain gauges is 45 degrees. ठीक है ना? So strain gauges में difference of 45, it can be said as 45 degree strain gauge.
Okay.
ठीक है जी? So this pattern is referred to as a strain rosette, and once the normal strains on the three strain gauges are measured, the data can then be transformed to specify the state of the strain at the point. Since these strains are measured only in the plane of the gauges, and since the body is stress-free on its surface, the gauges may be subjected to plane stress but not plane strain. ठीक है? ये मैं आपको एक्सप्लेन करता हूँ. Let me complete. Although the strain normal to the surface is not measured, ठीक है जी? What we are saying that when there will be a load will be applied, let's say the load is applied in x direction, so that is, let's say sigma x. So sigma x will produce the strain epsilon x, and due to the normal strain epsilon x, there will be a strain in the lateral direction, let's say that is epsilon y, ठीक है जी, due to the Poisson's effect. But the strain gauge can only measure the strain in the direction. Let's say if it is attached in the x direction, it can only give you epsilon x. It cannot give you epsilon y. If you want to measure epsilon y, you have to put the strain gauge in the y direction. Although the strain normal to the surface is not measured, realize that out of the plane displacement caused by this strain will not affect the in-plane measurements of the gauges. ठीक है जी? So this point is that your strain gauge, which is measuring the strain in the normal direction, so the strains being produced due to the Poisson's effect in the lateral direction, they will not affect the value of the strain in the normal direction. So lateral strains will not affect the normal strains. Fine. So any question from this whole paragraph? First thing, we have defined the electrical resistance strain gauges. The second thing they have defined is the strain rosette, which is a cluster of electrical resistance strain gauges, minimum 3 ठीक है जी and then we have said that from this we get epsilon a epsilon b epsilon c theta b theta c what we need from this raw data is to calculate the plane state of the strain that is we need to calculate epsilon x epsilon y and gamma xy ठीक है जी and from that data ठीक है जी we can calculate the principal strains or maximum in plane shear strain which are of advantage to us ठीक है जी so in the general case the axes of the three strain gauges are arranged at the angle theta a theta b and theta c so theta a theta b and theta c point shown in figure 1016a if the readings are epsilon a epsilon b epsilon c we can determine the strain component. So this is your plane state of the strain epsilon x, epsilon y, and gamma xy. Okay, so these are your what you say strain component, plane state of strain at the point by applying the strain transformation equation. Now, how these equations are derived? Okay, this is the main thing to be understood. Okay, so first thing is we need to see that how this equation is derived. If we go back to the strain transformation derivation, in your epsilon x dash derivation, so there was just right beyond before this adding the identities, you had this was your final equation for the computation of transformed normal strain about x dash axis ठीक है जी but this final version before this final version you had this version epsilon x dash is equal to epsilon x cos square theta plus epsilon y sin square theta plus gamma xy sin theta cos theta and in this equation you have put the identities and then you simplify and then you got this your final equation. So you can say a second last equation, this one, epsilon x dash is equal to epsilon x cos square theta plus epsilon y sin square theta plus gamma xy sin theta cos theta. So in this equation, okay, so what we are doing, this is the main equation we are using now. Okay, so let's say for strain gauge A, this equation will become epsilon A, the normal strain that it has measured, is equal to epsilon x cos square theta a plus epsilon y sin square theta a plus gamma xy sin theta a cos theta a. Look over here. Epsilon a is equal to epsilon x cos square theta a plus epsilon y sin square theta plus gamma xy sin theta a cos theta. Then come back. Now, if we put epsilon b, so if this is epsilon b, it will be equal to epsilon x cos square theta b plus epsilon y sin square theta b plus gamma xy sin theta b cos theta b. Okay, then you can see this epsilon b is equal to epsilon on x cos square theta b plus epsilon y sin square theta b plus gamma xy sin theta b cos theta b. Then for the theta epsilon c is equal to epsilon x cos square theta c plus epsilon y sin square theta c plus gamma xy sin theta c cos theta c. Okay, you will get this equation. So if this is asked that how we derive the equation or if there is a question, okay, derive this equation. So basically the derivation of this equation is up till here before the before adding the identities in the equation. So this is the derivation for strain rosette up till here. Okay, not this step. Excluding this step, this up till this point is the derivation of the strain rosette. Okay, so now you see this. In the general case, the axes of the three strain gauges are arranged at the angles theta A, theta B, theta C as shown in figure 1016A, this one. ठीक है जी, थीटा ए, थीटा बी, थीटा सी. So by applying the strain transformation equation 10-2, ठीक है जी, for each gauge 10-2 ये वाली equation, this one. So for each gauge we have epsilon A is equal to epsilon x cos square theta A plus epsilon y sin square theta A plus gamma xy sin theta A cos theta A. Epsilon B is equal to epsilon x cos square theta B plus epsilon y sin square theta B plus gamma xy sin theta B cos theta B. Epsilon C is equal to epsilon x cos square theta C plus epsilon y sin square theta C plus gamma xy sin theta C cos theta C. ठीक है जी. Now see this. You have from the strain data, you have epsilon A, epsilon B, epsilon C. You have theta A, theta B, theta C. Only unknown is epsilon x, epsilon y, and gamma xy. So if you solve these three equations simultaneously, ठीक है जी, if we solve these three equations simultaneously, we will get the unknowns epsilon x, epsilon y, gamma xy. So these values of epsilon x, epsilon y, gamma xy are determined by solving these three equations simultaneously. Is this point clear? If you have any query, please ask me now.
सर जिस तरह आपने बोला कि मिनिमम 3 जो है वो स्ट्रेन गेजेस रिक्वायर है, तो मैक्सिमम की भी कोई लिमिट है या नहीं हमारे पास?
Actually there can be more than 3, ठीक है जी, but in general we use 3 strain gauges, 3 strain gauges, ठीक है. और अगर 4 होंगे तो sometimes it happens कि वो जो 4 वाला होता है that cannot be solved easily using these calculators. उसके लिए फिर जो होता है कि we need Excel to solve it, ठीक है. For what? So in our case, we will limit it to strain gauge, 3 strain gauges in the strain gauge. G for what?
सर इस तरह तो ये x डायरेक्शन में ही हमें सारी स्ट्रेन की वैल्यूज मिलेंगी y के अंदर, और हमने क्यों नहीं फाइंड?
एक सेकंड. We are not defining x and y. We are not saying x and y. ये देखें. We have just considered this case. So x तो ये है. You have attached the strain gauge in a direction, theta a direction, you are getting the strain A. ठीक है जी, it's not ठीक है जी, it's not what you say x direction or y direction. This is direction is defined theta A with reference to x-axis. It is in some attached at some an angle. ये y नहीं है, this is not z. They are attached in different direction. अगर इस तरह अरेंज है तो ये basically x direction में अरेंज है. और then when you are solving this system, you do not epsilon A, epsilon B, and epsilon C.
सर ये ट्रांसफर तो x डायरेक्शन, उसके कंपोनेंट के रिएक्शन उसके x
उसमें the thing is उसमें we are see, अगर हम इसका सिर्फ स्ट्रेन लें, ठीक है जी, just for the understanding I'm letting you know, if you just take the strain in this direction, ठीक है, then it can be epsilon y. But once you are including thetas, ठीक है, once you are including the thetas and you are solving the system in simultaneous way, in that case it is not your epsilon y or this is not your epsilon x. ठीक है जी, these are arranged in one particular direction which is defined by value of theta. ठीक है. इसको आप इससे कंफ्यूज ना करें कि वेदर दे आर एक्स वाई और जी। जैसे यू कैन सी दिस, अब ये वाली जो डायरेक्शन है, ठीक है, आपने एप्सिलॉन एक्स एप्सिलॉन वाई इससे भी तो कंप्यूट करना है, ठीक है, because they are defined, they are specified by the value of theta. अगर आपने सिंपल एप्सिलॉन एक्स और एप्सिलॉन वाई लेने, then you do not need this, ठीक है, आपको ये सिस्टम नहीं चाहिए, you just put one strain gauge along x direction, one along y direction, you get the value, ठीक है कि
ओके
नहीं,
सर,
ठीक है,
थैंक
लेकिन
यू।
उसमें फिर आपके पास shear strain नहीं है। When you will solve this complete system, then you are going to get shear strain, ठीक है, otherwise you are not going to get the shear strain, ठीक है। अब जब आप इसमें भी ले रहे हैं तो you cannot say the strain it is epsilon x, this strain is epsilon a, this strain is not epsilon y, this strain is epsilon c. Now you have three strain gauge data, you have three values of theta, solve these three equations simultaneously, and the answers that you will get, they are plain state of strain, they are plain state of strain, okay. So these values of epsilon x, epsilon y, gamma xy are determined by solving these three equations simultaneously. I hope this point is clear, ठीक है। These strain
Yes, sir.
gauges are identified with the value of theta, ठीक है, they are defined by thetas. Okay, next is the values of epsilon x, epsilon y, and gamma xy are determined by solving these three equations simultaneously. Strain rosettes are often arranged in 45 degrees or 60 degrees pattern. Strain rosettes are often arranged in 45 degrees or 60 degrees pattern. ठीक है जी, in the case of 45 degrees or rectangular strain rosette, guys please note down this name, ठीक है जी, 45 degrees or rectangular strain. In some questions they are just mentioning rectangular strain rosette, ठीक है, तो उसमें वो degrees नहीं mention करते। So this is the case. In this case you can see I am going to measure my value of theta with respect to horizontal x-axis. So this theta a will be, what will be the value of theta a?
0.
0 degree.
0. Theta a is 0, and moving from x, positive x-axis towards b, it will be theta b. We are moving in counterclockwise, so theta b will be 45 degrees. Then moving from x-axis to the strain gauge c, theta c will be 90 degrees. Theta c will be 90 degrees, ठीक है जी, theta c will be 90 degrees. Fine.
Yes, sir.
Okay. Now what they are doing, I do not want you to remember this, ठीक है, because this is you just need to know these main equations. So in these equations basically what they are doing, they have put theta a 0, theta b 45, theta c 90, ठीक है जी, and then they have simplified it, and then you are getting these equations that epsilon x is equal to epsilon a, epsilon y is equal to epsilon c, and gamma xy is equal to this, ठीक है। So you just need to focus on this thing, you just need to focus on this thing, ठीक है, whatever the value of theta may be, ठीक है। Then the another commonly used strain rosette is 60 degrees. Theta A is 0, theta B 60, theta C is 120 degrees. And you can see this, we are getting these values. No need to remember, just focus on this main equations, and just you need to know how to solve these equations, and you will get your required values of plane state of strain. Any questions? एक चीज रहेगी, let me explain to you that once you have your plane state of strain, the transformation equations, or your transformation equations, the one which we have derived, epsilon x dash equation, epsilon y dash equation, or gamma x dash y dash equation can be used, or we can use the Mohr circle, ठीक है जी, to determine the principal in-plane strains and the maximum in-plane shear strain. So basically, strain rosette will be used to find out this thing, plane state of strain. Once the plane state of the strain is identified, next you can use either the equations or the Mohr circle, depending what has been asked in the question. You can calculate the principal strains and maximum in-plane shear strain. Is this point clear?
Yes,
Yes, sir.
So let's start the numerical. Let's start the numerical. So the state of the strain, ठीक है जी, the state of the strain at a point A. Guys, do you have the calculators and the pencils?
yes,
Yes, sir.
Yes, sir.
Okay. The state of the strain at point A on the bracket, ठीक है जी, ये bracket है, ठीक है. At one point they have placed this strain rosette. So sorry. So these are three strain. This is strain gauge A, strain gauge B, strain gauge C. ठीक है जी. So the state of the strain at point A on the bracket is measured using the strain rosette shown in figure 1017B. ये उसने figure भी draw कर दी. ठीक है जी. Due to the loadings, the readings from the gauge strain gauges are epsilon A कितना है जी आपका 60 microstrains, epsilon B कितना है जी, that is 135 microstrains, epsilon C is 264 microstrains. Fine. Now we are required to calculate in-plane principal strains and the direction. Fine. So first we have to calculate theta. Theta A आपका कितना होगा जी?
0, sir.
0 degrees with respect to positive x-axis 0. Theta B is 60 degrees. Theta C is 120 degrees. Guys, now using this equation, please put the value and first put the values and then simplify. And then please let me know the value of epsilon x, epsilon y, and gamma xy. Epsilon A is 60, epsilon B is 135, ठीक है जी. Epsilon C is 264, theta A is 0, theta B is 60, theta C is 120 degrees. Fine. Fine. So please write the equation. You can see there I have written. So this is epsilon A, let's say for first 60 microstrains, epsilon X cos square, theta is 0, epsilon Y sine square, theta B, this theta A 0 plus gamma xy sine theta cos theta A. So equation 1 is okay.
yes, sir.
Then comes equation 2. Epsilon B is equal to epsilon x cos square theta b plus epsilon y sine square theta b. plus gamma xy sine theta b cos theta b. So theta b is 60 degrees, epsilon b is 135 microstrains.
Yes sir, यही इक्वेशन बनती है.
Then epsilon c is equal to epsilon x cos square theta c plus epsilon y sine square theta c plus gamma xy sine theta c cos theta c. Theta c moving from x axis, positive x axis in the counterclockwise direction. Theta c is 120 degrees. 120 degrees. Please calculate epsilon x, epsilon y, and gamma xy.
Sir, 60 microstrain, 246 and minus 9 EXU and gamma xy respectively.
Minus 149 microstrain. ठीक है जी, everyone is clear with this?
Yes sir.
Everyone has solved it. ठीक है जी, so epsilon x is 60 microstrains, epsilon y is 246 microstrains, and gamma xy is minus 149 microstrains. ठीक है जी, minus 149 microstrains. ठीक है जी. Now in the question it was asked to calculate in plane principal strains. ठीक है जी, you can calculate principal strains. In this case I would like you to calculate using the equations, because we have done number of numericals with what you say, with the help of this Mohr circle. So just putting the value, what you say, equation, calculate principal strains, and let me know the answer. If you find any difficulty, also ask me so that we can solve this.
Yes sir, same answer. Epsilon 1 or epsilon 2.
You have used the equation now.
Yes sir.
The one thing you can see what they are doing, they have calculated the resultant, which is epsilon x minus epsilon y over 2 square plus gamma xy over 2 square, and under root of this they calculated r. Then epsilon 1, this one. So epsilon 1 is simply epsilon 1 is
एवरेज स्ट्रेन प्लस रेडियस,
एवरेज स्ट्रेन प्लस रेडियस, एवरेज स्ट्रेन माइनस रेडियस, ठीक है जी। ये यू कैन नाउ सी दिस एज वेल। एंड थीटा पी। उजैर, आप लोगों की क्लास कैलकुलेट कर रही है कि नहीं? तो थीटा पी, ओरिएंटेशन ऑफ द प्रिंसिपल प्लेन्स।
सर 38.7 आ रहा है टू थीटा पी।
आपका टू थीटा पी आ रहा है ना?
यस
ठीक
सर।
हो गया, चल। So with this, strain rosette is over. ठीक है जी। I will also give you the some problem statements later on. चलें, ये थोड़ी सी प्रैक्टिस के लिए ना हम एक चीज करते हैं कि हम ये वाले जो एंगल्स हैं इनको डिसाइड कर लेते हैं कि ये क्या है, बिकॉज इस only in the what you say computation of angle. अगर एंगल ठीक है तो most probably you will do it correctly. अच्छा जी, what will be the value of theta a? We are just doing this one. So what is the value
60
of
degree.
theta
60.
a?
60 sir.
60 degree. Positive 60. ठीक है? And moving from horizontal x-axis towards b, so theta b will be
120.
120.
120. 60 plus 60, 120. And theta c will be
180.
180. Correct. इधर से आ रहे हैं। थीटा ए विल बी
180.
180। चलें ठीक है, मैं आपको दूसरा भी बता देता हूँ। थीटा ए इज 180, थीटा बी 180 plus 40, 225, थीटा सी इज 270 degrees. Another thing, ठीक है, एक है कि अगर आप give this question in the exam, ये वाला था वो, तो some students have done this question in this way. They have taken theta a 0, theta b उसने लिया -45, theta c उसने लिया -90. ठीक है जी, he also got the same answers. ठीक है, हम ले रहे हैं with respect to positive x-axis, theta a 180, theta b 225 degrees, theta c 270 degrees. उस स्टूडेंट ने लिया थीटा ए 0, थीटा बी -45, थीटा सी -90. आई स्टिल रिमेंबर ही गॉट द सेम आंसर्स. तो ये आप लोगों ने चेक भी करना है और ये चेक करके मुझे बताना भी है, ठीक है? आपके आप लोग जरा इसको चेक करें। फवाद,
एंटी क्लॉकवाइज है तो ये तो पॉजिटिव 40 आना था, नेगेटिव को भी लिया है तो पॉजिटिव 45 और पॉजिटिव 90।
सर वो एक्चुअली ये है कि x की डायरेक्शन अपोजिट को उसने कर दी है ना, फिर इस वजह से फिर शायद माइनस के साथ
ये था कि उसने, आई स्टिल रिमेंबर, उसने इसे थीटा ए 0 लिया, इसे उसने -45 लिया, इसे उसने -90 लिया। अगर आपके आई थिंक सो, अगर जैसे तुम कह रहे हो ना, उससे आंसर शायद सही ना आए। ये आप लोग जरा चेक कर लें और ये मुझसे भी जरा शेयर कीजिएगा, ठीक है? एक तो रेगुलर आपका हो गया ना, थीटा ए 180, थीटा बी 225, थीटा सी 270. द अदर ऑप्शन वी आर सेइंग थीटा ए 0, थीटा बी -45, थीटा सी -90. ये आप लोग जरा चेक करके मुझे बताएं।
सर अगर इसको हम वैसे अगर क्लॉकवाइज ले लें -90 एंड -135 सेम आएगा
probably that's also true. ये वाला भी ठीक है, थीटा ए होगा, थीटा सी विल बी 135, ये तो सिंपल है, इसमें तो कोई इशू नहीं. चलें, let's start with our new topic, material property relationships. Material property relationships. Material property relationships. ठीक है जी. In this section, we will present some important relationships involving material properties. Material properties आपकी हैं modulus of elasticity, modulus of rigidity, Poisson's ratio. ठीक है जी. So we will use them, ठीक है जी, to interrelate stresses and strains, to relate stresses with strains. So in this section, we will present some important relationships involving material properties that are used when the material is subjected to multi-axial stresses and strain. To do so, we will assume that the material is homogeneous, isotropic, and linear elastic. There are three assumptions. Linear elastic. Linear elastic means that the stresses are directly proportional to the strain. And once you will remove the stress, the strain will be removed and the body will come to its original position. There is no permanent deformation. When you are in the inelastic range, then what will happen when you will remove the body, when you will remove the stress from the body will not come back to its original position. There will be some inbuilt inelastic deformations. Okay. Then, so linear elastic also means that the Hooke's law is applicable. ठीक है जी. Hooke's law is applicable. Hooke's law is applicable because the relationships that we are going to develop, in those relationships, it's important basically to ensure that the Hooke's law is applicable. So linear elastic means that the Hooke's law is applicable. Isotropic means material has same properties in different directions. It has same properties in different directions. Steel is an isotropic material. Steel is isotropic material having same properties in different directions. And this is one of the major advantage of steel as well. Because when you want to do numerical work, when you want to do numerical work, when you want to do modeling, so see, it's much easier to model steel than to model any non-isotropic or orthotropic material like fiber reinforced polymers, because they have different properties in different directions, like X, Y, and Z direction. They have different properties. So steel is an isotropic material, meaning it has same properties in different directions. So which is a big advantage of steel. Big advantage of steel. Homogeneous. Homogeneous means you can say that steel, it comprises of fibers and epoxies, and both have the same material behavior. Okay. On the other hand, you have heterogeneous materials. Can you name any heterogeneous materials? आप लोग PRC 1 पढ़ रहे हैं. In PRC 1 concrete is heterogeneous. Basically, the behavior is, material behaviors are different. Okay. So over here we are studying, we are assuming that the material is homogeneous, isotropic, and behaves in linear elastic manner. Please note down these 3 points. Okay. So according to material property relationships, if we can ask you what are the assumptions, you should know that. Done with this?
Yes, sir.
Done with this? Okay. Now we are going to use these three assumptions: homogeneous, isotropic, linear, elastic. So if the material at a point is subjected to a state of triaxial stresses, sigma x, sigma y, sigma z, ठीक है जी, figure 1018a is this figure, ठीक है जी. I can explain to you this figure what we are doing here. This is your element, ठीक है जी, this is your element. Fine, it is subjected to sigma x, sigma z, sigma y, ठीक है जी. So it's a three-dimensional element. All these three stresses are tensile stresses producing tensile strains resulting in the elongation of the element in all. Clear? Clear? Now,
Yes, sir.
now
Yes, sir.
due to the Poisson's effect, ठीक है जी. Now take the example of the Poisson effect. This is sigma x, ठीक है जी. Sigma strain epsilon x in x direction, and it will produce lateral strains in y and z direction due to the Poisson's effect. Meaning to say, due to sigma x, there is a normal strain epsilon x. So a proportion of epsilon x will be acting along the y direction, and a proportion of epsilon x will be acting along the z direction due to the Poisson's effect. ठीक है जी. और epsilon x is positive, so lateral strain due to the Poisson's effect in y and z direction because of epsilon x will be negative. ठीक है जी, will be negative. Okay, then comes sigma y. Sigma y will produce a normal strain epsilon y in y direction. Positive strain, positive stress, positive strain. Now a component of epsilon y will be acting along x and z direction, ठीक है जी, due to the Poisson's effect, ठीक है जी, and that will be negative sign, ठीक है जी. Those lateral strains, they will be producing contraction, ठीक है जी, producing contraction about x and z direction. Fine. Then comes you have sigma z. It will produce normal strain epsilon z, and due to the lateral strain, due to the Poisson's effect, it will have a lateral strain in x and y direction. ठीक है जी. Now, if you see this along the x direction, how many strains are there along the x direction now? Along the x direction, you have one normal strain epsilon x, ठीक है, and you have two lateral strains along the x direction due to the normal strain epsilon y and due to the normal strain epsilon z, ठीक है जी. So there are three strains, one normal strain and two lateral strains in x direction. Okay, how many strains are there in the y direction? Three strains, one normal strain epsilon y and two lateral strains due to epsilon x and epsilon z. Similarly, about sigma z, how many strains are acting in z direction? Three strains are acting in z direction. Normal strain epsilon z and two lateral strains, one due to epsilon x, other due to epsilon y. ठीक है जी. So there are three strains are acting in the z direction. Guys, did you get this concept? If you have any query, please ask me.
No, sir, clear.
ठीक है जी. So in each direction, you have one normal strain and two lateral strains, ठीक है जी, due to the Poisson's effect. And why you have two lateral strains? Because you are having triaxial stresses. Fine. So you can see now this is the combined figure showing the elongation of all the dimensions of the element. One more thing to be noted that I have said that along the x direction, normal strain is producing positive strain and the lateral strains, they are negative. but normal strain is larger in magnitude than the lateral strain. So net effect is elongation in the x direction. Similarly, net effect in the y direction is also elongation. Net effect in the z direction is also elongation. Epsilon z is greater than the lateral strains due to epsilon x and epsilon y. So net result is elongation in all three directions. Now you see this. We have split this in three parts. So this is your element. Due to sigma x, we are showing the net, you can say the elongation in the x direction. Okay, so the element is elongated in the x direction due to the due to the applied sigma x. Then due to sigma y, this is the elongation about the y-axis. Then due to sigma z, this is the elongation along the z-axis, and net you will get this figure. Okay, if you have any query, please ask me.
No, sir.
Clear?
Clear.
चलो अभी पता चल जाता है. Because now I'm going to explain this. So if the material at a point is subjected to a state of tri-exercise, means on an element you have sigma x, sigma y, and sigma z. On the element, three stresses are acting, tri-axial stress. So associated normal strains will be developed in the material. Agree. Sigma x will produce epsilon x, sigma y will produce epsilon y, sigma z will produce epsilon z. The stresses can be related to these strains by the principle of superposition. Poisson's ratio and Hooke's law. Poisson's ratio क्या है? Lateral strain is equal to minus, ठीक है जी, in opposite direction times the Poisson's ratio times the longitudinal strain. ठीक है जी, so what is the value of the lateral strain? Lateral strain is minus times the Poisson ratio times the longitudinal strain. And Hooke's law. Hooke's law, stress is directly proportional to the strain within the elastic limit. So we have already assumed that we are working within the elastic limit. Okay? So as is and Hooke's law as it applies in the uniaxial direction. Uniaxial means ये उसने अभी आपको सिग्मा एक्स एप्सिलॉन एक्स, सिग्मा वाई एप्सिलॉन वाई, सिग्मा सी एप्सिलॉन जी, एक डायरेक्शन. वी आर टॉकिंग अबाउट यूनिएक्सियल dimension. ठीक है, we are not talking about the lateral strains at present. ठीक है, जब lateral strains की बात आएगी, then we will consider this one. Lateral strain is equal to minus times the Poisson ratio times the longitudinal strain. Hooke's law is stress is directly proportional to the strain. So strain is equal to stress over modulus. ठीक है जी, so just we have rearranged the equation. Strain is equal to stress times strain is equal to stress over modulus of elasticity. Strain is equal to stress over modulus of elasticity. For example, consider the normal strain of the element in the x direction caused by separate application of each normal strain. ठीक है जी. So now what we are going to do, we are going to calculate the strains in x direction. ठीक है जी. We are going to calculate the strain in x direction due to sigma x, sigma y, and sigma z. Sigma x will produce epsilon x, sigma y will produce epsilon y, sigma z will produce epsilon z. Everyone agrees to this point?
Yes, sir.
ठीक है. So, for example, consider the normal strain of the element in the x direction caused by separate application of each normal stress. When sigma x is applied, ठीक है जी, sigma x is applied, the element elongates in the x direction, and the strain produced in the x direction is epsilon x dash is equal to sigma x over e. ठीक है जी, this is the normal stress and this is the normal strain in the x direction. ठीक है, normal strain in the x direction. Agree to this point?
Yes, sir.
Now application of sigma y. Sigma y is the normal strain stress in the y direction, so it will produce a normal strain in the y direction, that is epsilon y. Now sigma y is tensile stress, it will produce tensile strain epsilon y, but in the lateral direction we will have negative effect. ठीक है जी, अगर along the longitudinal axis it is producing elongation, then in the lateral direction it will produce contraction. So application of sigma y causes the element to contract with a strain epsilon x double dash. उसको उस lateral strain को represent किया है epsilon x double dash. So epsilon x double dash due to sigma y is sigma y over e is epsilon y times the Poisson ratio times the negative sign. ठीक है जी, epsilon x double dash produced due to the application of sigma y causes the element to contract. ठीक है जी, sigma y over e is epsilon y times the Poisson ratio times the negative sign. So you will get epsilon x double dash. Is this point clear?
Yes sir.
आगे चलते हैं. Likewise, application of sigma z causes a contraction. Contraction क्यों cause हो रही है? Because in the longitudinal direction there is sigma z is producing elongation, but in the lateral direction the effect of sigma z, that is epsilon z, will be opposite, so causes a contraction. So epsilon x triple dash, ठीक है, is equal to epsilon z, ठीक है जी, sigma z over e epsilon z times the Poisson ratio times the minus sign. ठीक है, is this point clear?
Yes sir.
ठीक है जी, तो नेट आपका क्या, सो x डायरेक्शन में आपका टोटल सम क्या हुआ? लेट मी कम हियर, मैं ना आपको अपनी हैंड रिटन से दिखाता हूं. So net strain in x direction is epsilon x is dash is equal epsilon x is equal to sigma x over e minus mu times sigma y over e minus mu times sigma z over e. ऐसे ही है. Agree with this point?
Yes sir.
ठीक हो गया. ये in the book they are showing what you say only positive दिखा रहा है ये. ठीक है, let me show you explain to you. Let's say I want to calculate the strains in y direction. ठीक है जी, हम y direction में calculate करना चाहते हैं. So in the y direction sigma x will produce, या इसको ऐसे करें, when sigma y is applied the element elongates in the y direction. तो strain क्या होगा? epsilon dash y epsilon y dash is equal to sigma y over e. तो ये आपका हो गया normal strain in the y direction. Then application of sigma x, ठीक है, causes the element to contract with a strain epsilon you can say y double dash. वो क्या हो जाएगा? epsilon y double dash will be equal to sigma x over e. तो ये epsilon x आ गया times the Poisson ratio times the minus sign. ठीक है, ये as it is आ जाएगा. Sigma z will cause a contraction such that epsilon y triple dash is equal to sigma z over e times the Poisson ratio times the minus. ठीक है, और अगर हमने कैलकुलेट करना है the effect of like the stresses in the z direction, तो z में क्या होगा? Let's say this is epsilon z dash is equal to sigma z over e. ठीक है जी, then application of sigma y causes the element to contract with a strain epsilon z double dash. Value will be same. Epsilon z double dash will be equal to sigma y over e times Poisson ratio times the negative sign. And application of sigma x, तीसरा strain आपका sigma x ही है ना, that will causes a contraction such that epsilon z triple dash will be equal to what you say sigma x over e times the Poisson ratio times the negative sign. ठीक है, what will happen? sigma x is equal to sigma x over E minus times mu sigma y over E minus mu times sigma z over E. तो एप्सिलॉन y आपका क्या होगा? एप्सिलॉन y will be equal to sigma y over E minus mu times sigma x over E minus mu times sigma z over E. And epsilon z आपका क्या होगा? Sigma z over E minus mu times sigma y over E minus mu times sigma x over E. ठीक है जी, ये कॉन्सेप्ट क्लियर हो गया that in each direction there will be one normal strain and two lateral strains. Everyone agrees to this point?
Yes, sir.
Yes, sir.
हल्का हो गया वैसे? यस। आप लोगों ने एक चीज करनी है आफ्टर द लेक्चर, इसको खुद भी करना है, एंड इफ यू फाइंड एनी डिफिकल्टी यू कैन एक्सप्लेन, यू कैन आस्क मी। ठीक है जी। सो नाउ द सिंपलीफाइड, सो एप्सिलॉन एक्स का ये आ गया सिग्मा एक्स ओवर ई माइनस म्यू टाइम्स सिग्मा वाई ओवर ई माइनस म्यू टाइम्स सिग्मा जी ओवर ई। ठीक है जी। तो सिग्मा एक्स आपका क्या होगा? सिग्मा एक्स इज इक्वल टू 1 over e, they have taken it as common, so 1 over e bracket sigma x minus times mu, ठीक है, sigma y, this minus and this minus will become plus, so plus sigma z. So in the same way you will get the equations for the normal strain epsilon y and epsilon z. epsilon y आपका क्या आ रहा है? 1 over e times sigma y, ठीक है जी, नॉर्मल जो उसका स्ट्रेस होगा इन दैट डायरेक्शन, माइनस म्यू टाइम्स sigma x plus sigma z. Epsilon z is equal to 1 over e times sigma z minus mu times sigma x plus sigma y. ठीक है जी। Now you can see this. You have applied, you are calculating the strain from the stresses. ठीक है जी, you are calculating the strain from the stresses without measuring it. ठीक है, आपने just stress measure किया and you have calculated the strain. These equations represent Hooke's law in a general form for a triaxial state of the stress. How many of you agree with this?
Yes, sir, agreed.
Okay, tensile stresses are considered positive as they produce positive strains resulting in the elongation in the material. Compressive stresses are considered negative as they produce negative strains contraction in the material. Okay, let's come back to the book. ठीक है जी। So these three equations, just repeat, express Hooke's law in a general form for a triaxial state of the stress. For application, tensile stresses are considered positive and compressive stresses are considered negative. If a resulting normal strain is positive, it indicates that the material elongates, whereas a negative normal strain indicates the material contracts. ठीक है जी। Now ये तो हो गया आपका नॉर्मल स्ट्रेस का था, ठीक है जी, सिग्मा एक्स सिग्मा वाई सिग्मा जी. Now comes the shear stresses. Now in the triaxial stress state we have said that we have 3 normal stresses and 3 shear stresses. Normal stress आपका था sigma x sigma y and sigma z, and the shear stress you had tau xy tau xz tau yz. There are 3 shear stresses. Now consider this. Before considering this, I will show you the figure. This is tau xy, effect of tau xy on the element, effect of tau yz on the element, tau xz on the element. ठीक है, ये आपको effect आया. अब now let's read. There is a difference now. If we now apply a shear stress, let's say tau xy, आपके पास 3 shear stresses हैं, tau xy, tau xz and tau yz. So if we now apply a shear stress tau xy to the element, experimental observations indicate that the material will deform only due to the shear strain gamma xy. Means to say shear stress tau xy xy will only produce the shear strain gamma xy. It will not produce a component which is like gamma xz or gamma yz. Shear stress tau xy, experimental observations indicate that the material will deform only due to the shear strain. So tau xy will only produce gamma xy shear strain. That is, tau xy will not cause other strains in the material. This is the important point. Please note it down. ठीक है जी. Similarly, shear stress tau yz and tau xz will only cause shear strain gamma yz and gamma xz. So according to the Hooke's law कहता है कि shear stress is directly proportional to the strain, and the sign of proportionality is replaced as your modulus of rigidity. So shear stress is equal to, basically shear stress tau xy is equal to g times gamma xy. So when you rearrange the equation, shear strain, if you take it outside, so gamma xy is equal to tau xy over g. So in this case, because we are saying that the shear stress tau xy will only produce the shear strain gamma xy, it will not produce any component of the strain like gamma xz or yz. ठीक है जी. So simply we can say the shear strain gamma xy is equal to tau xy over g, and gamma yz will be equal to tau yz over g. Gamma xz is equal to tau xz over g. ठीक है. डिफरेंस ये है कि इन केस ऑफ नॉर्मल स्ट्रेन ड्यू टू द पोसॉन्स इफेक्ट, ठीक है जी, लेटरल स्ट्रेन्स आर प्रोड्यूस्ड. However, in shear strain there is no such observation. Shear stress xy will only produce shear strain xy. Shear stress xz will only produce shear strain xz. Shear stress yc will only produce shear strain yc. ठीक है जी. Any questions about this, guys?
No, sir.
आप लोगों ने एक काम करना है बिफोर वी डू इन द नेक्स्ट क्लास, के आप लोगों ने ये वाली जो इक्वेशन है इसकी फुल डेरिवेशन जो मैंने आपको एक्सप्लेन की है फॉर y एंड z वो भी करनी है, एंड यू विल शेयर इट. सीआर जो है वो मेरे साथ ग्रुप में शेयर कर दे on my WhatsApp, and then if it will be correct, then I will let you know to share it with your class fellows as well. Guys,
Okay,
any
sir.
question from today's lecture?
No, sir.
एक second, let me download the attendance. Download attendance. Guys, thank you very much for your time. I have downloaded the attendance. You have given extra time. I will be requiring some extra time next week as well.
Okay, sir.
Okay, guys. Take care and have happy weekend.
Okay, sir. Allah Hafiz.
Allah Hafiz. Take care, guys.